Welcome to the chapter on hydraulics and hydrology. These are fundamental topics in civil engineering that deal with the behavior of water in various environments. In this chapter, we will cover fluid mechanics, open channel flow, and stormwater management. Understanding these principles is crucial for designing and managing water-related infrastructure. Fluid mechanics is the study of fluids, which include both liquids and gases, and the forces acting on them. It is essential for understanding how water moves through different systems. Let's start with the basic properties of fluids. Density, denoted by the Greek letter rho, is the mass per unit volume of a fluid. For water, it is approximately 1,000 kilograms per cubic meter. Viscosity, represented by the Greek letter mu, measures a fluid's resistance to deformation. Water has a low viscosity compared to other fluids like oil. Pressure, denoted by P, is the force exerted by a fluid per unit area and is measured in pascals. The continuity equation is a statement of the conservation of mass in fluid flow. For an incompressible fluid, it is given by A1V1 equals A2V2, where A1 and A2 are the cross-sectional areas at 2 points in the flow, and V1 and V2 are the flow velocities at these points. Bernoulli's equation relates the pressure, velocity, and elevation in a moving fluid. It is given by P plus 1/2 rho V squared plus rho GH equals a constant. Here, P is the pressure, rho is the fluid density, V is the flow velocity, G is the acceleration due to gravity, and H is the elevation. Consider water flowing through a pipe that narrows from a diameter of 0.5 meters to 0.25 meters. If the velocity in the wider section is 2 meters per second, what is the velocity in the narrower section? Using the continuity equation, A1V1 equals A2V2. The area A of a circular pipe is given by pi times the radius squared. For the wider section, A1 is approximately 0.196 square meters. For the narrower section, A2 is approximately 0.049 square meters. Solving for V2, we get V2 equals 8 meters per second. Open channel flow refers to the flow of water with a free surface, such as in rivers, canals, and drainage ditches. There are two types of flow in open channels. Uniform flow, where the flow characteristics like velocity and depth remain constant along the channel length, and non-uniform flow, where these characteristics change along the channel length. Manning's equation is used to estimate the velocity of flow in an open channel. It is given by V equals 1 over n times r to the power of 2/3 times s to the power of 1/2. Here, V is the flow velocity, n is Manning's roughness coefficient, r is the hydraulic radius, and s is the slope of the energy grade line. Calculate the flow velocity in a rectangular channel with a width of 3 meters, a depth of 1 meter, a slope of 0.001, and a Manning's roughness coefficient of 0.015. First, calculate the hydraulic radius r, which is the area of flow divided by the wetted perimeter. The area A is 3 times 1, which equals 3 square meters. The wetted perimeter P is 3 plus 2 times 1, which equals 5 meters. So r is 3 divided by 5, which equals 0.6 meters. Using Manning's equation, V is approximately 1.03 meters per second. Stormwater management involves controlling and using stormwater runoff to minimize flooding, erosion, and water pollution. Key components of stormwater management include detention basins, which temporarily hold stormwater and release it slowly, retention basins, which hold stormwater permanently, allowing it to infiltrate into the ground, and green infrastructure, which includes practices like green roofs, permeable pavements, and rain gardens that mimic natural processes to manage stormwater. The rational method is used to estimate peak discharge from a small watershed. It is given by Q equals CIA, where Q is the peak discharge, C is the runoff coefficient, I is the rainfall intensity, and A is the drainage area. Estimate the peak discharge from a 2-acre parking lot with a runoff coefficient of 0.9 and a rainfall intensity of 3 inches per hour. Using the rational method, Q equals CIA, which equals 0.9 times 3 times 2, resulting in 5.4 cubic feet per second. This tutorial provided an overview of the key concepts in hydraulics and hydrology for first-year civil engineering students. Understanding these principles is crucial for designing and managing water-related infrastructure. Thank you for watching.